Welcome to episode number 13 of Colorado TechCast.
Your organizational structure and your systems need to be in alignment. How do we restructure your org to match that? When you separate operations from support or reliability engineering, from product engineering, from your quality assurance team, you really get a misalignment of incentives. Everybody's intentions are good, but they're not aligned. That's one of the big things to work through is how do we align our teams and how do we build incentive structures so that everybody wants to ship a product that's at a suitable quality level.
This is Trapper from Colorado TechCast, the show that tells the stories of Colorado technology entrepreneurs and the companies that they're building. To hear new episodes of this program, go to our website at coloradotechcast.com. There you'll find everything you need to know to subscribe to the show with links to iTunes, SoundCloud, and everything else we talk about on the program. Today I'm speaking with Robert Kluin, Managing Partner of Real Kinetic. Robert, how are you doing today?
I'm doing well, Trapper.
Tell me a little bit about Real Kinetic.
Real Kinetic is a consulting company that myself and a few partners started. We kind of realized we had some unique skills with DevOps and building scalable software. So we decided to start a company and see if we could help some other group achieve some of the same results we've achieved.
Tell me about your background, your education, things that got you started in along this track.
Yeah, my background's kind of rambling and windy. I started out doing physical infrastructure back in the late 90s, so running network cables and building and installing servers, things like that. One of my first clients was actually a small oil transportation company, and I wound up helping them write some software to manage the shipments of crude oil. This was actually while I was finishing high school that I'd started all this, and then I wound up going to college, getting a degree in math, and ultimately going to grad school, pursuing a PhD in economics, which I quit because I enjoyed writing software more. Then I spent about 10 years writing oil and gas trading and accounting systems, and ultimately got into cloud computing, and then wound up at a company called Workiva, their head of architecture, and then ultimately running our infrastructure group. And then now I've started Real Kinetic. Okay.
So at Workiva, were there any specific areas that you focused on in terms of like development or software teams?
Yeah, my background, when I was first hired and started working with them, I worked with our core platform groups, developing our low-level cloud systems. Workiva is a unique company because it started in 2008, right at the beginning of really when cloud stuff was taking off, and we were one of the first cloud software vendors into a lot of the Fortune 100 companies. I was responsible for all the technical architectural decisions for a lot of the platform teams.
So where was Workiva based?
Yeah, that's another interesting little Workiva tidbit. They're actually based and headquartered in Ames, Iowa, which is where Iowa State University is located. The founding team were professors and grad students there back in the 90s. They started a company that they took public, then they all kind of retired a few years and started another company called Web Filings, which ultimately got renamed Workiva. Kind of a rare Midwestern tech success story.
It's like the Stanford of Iowa, right?
Yeah, exactly.
So what brought you out to Colorado?
I moved out to Colorado to open an office for Workiva in Boulder. I think that was in 2013, maybe in the spring of 2013. I moved out and we opened a core engineering office down on Walnut Street in Boulder.
So how did you transition from Workiva to Real Kinetic?
Well, my partners and I started kind of talking about what we really loved and enjoyed at Workiva, and we were the kind of core team responsible for building out and implementing a lot of the now trendy things like CI/CD systems, So we moved from quarterly releases to multiple releases a day. We split up a big production monolith into microservices, and we really were building out a lot of these things that are now catching on and becoming popular. And so when we were talking about it, we realized we really loved that early kind of growth stage at Workiva. So we decided to start a company and try to help some other companies achieve the kinds of results Workiva has achieved.
Mm-hmm. So kind of that early stage tech community?
Exactly. It's like that early stage, found some market traction, ready to grow, and it's time to productionize the systems and kind of make them a professionally done thing. That's the phase of the company we love, is that transition time where you're going from some demonstrated traction to really successful product. Mm-hmm. It's a hard stage for a company to make it through. There's usually a lot of employee growth, there's systems growth and demand, and it's just a really challenging time, and we're a weird group of people that found that extremely fascinating and fun to work on.
You like the chaos?
Yeah, exactly. It's really, you know what it is, the way we explained it is, like, me personally, I articulate my skill as making sense of chaos. Mm-hmm. It's kind of one of those things of like seeing opportunity in the chaos and then turning that into something much bigger.
When you first moved out from Iowa to Colorado or Iowa to Boulder, what were your impressions of the tech community here?
I was just absolutely blown away. I've lived all over the kind of central United States, and I used to travel to San Francisco and Seattle, usually a time or two a quarter. And so I've been around tech-heavy areas before, but when I moved out to Colorado, especially Boulder, Denver area, it's just, I don't know, it's like super energizing. All of the people trying to start companies, just loads of people that are super into tech, and it's really neat. One of the things we talk about a lot is that, and we kind of sell people on the area, so it's like you could probably go to a tech meetup almost every night on about whatever topic you find interesting. Mm-hmm. At least once a week you can find that. It's really cool.
Yeah. Somebody else I was talking to on a recent interview, he was from New York, and he was saying how active the tech community was out there. He said it was overwhelming almost because there were so many options.
Yeah.
And you had to make a lot of trade-offs. Personally, I haven't found that here as much. There's topics about everything that you want, but fortunately, there's not a whole lot of overlap. So if you want to go learn about cloud computing, there's a primary meetup for that. If you want to go learn about Bitcoin or blockchain, there's a primary meetup about that. So it's centralized enough to where you can see everything you want to see without having so many options that you're just paralyzed, and kind of dilutes the pool, so to speak.
Yep, I'd say that's definitely true. The other thing that I loved with our community here is that, I may be biased just with where I live and, my own personal interests. You also get this nice lifestyle in Colorado. I'm able to go out in the afternoon for a hike or a bike ride or something like that, mm-hmm. and then go to the tech meetups and find other people that are doing the same thing. And I've just found a really nice mix of, being indoors at my computer, but also it feels like a community that appreciates the fact that we live in such a beautiful area. I really find that to be kind of a unique thing that's really enjoyable.
Yeah, definitely. Yeah, there's a company here, I can't remember who it is, but snow days, they let their people go. Which,
yeah, powder days, yep.
Yeah, you wouldn't find that in many other places. So.
No.
So tell me more about Real Kinetic, like what you guys do in terms of consulting, size of companies, and any products that you have in the works.
Yeah, one of the interesting things we found, it kind of makes it hard for me finding new clients in a way, is that what we found is that so far worked with small shops that are like 5 engineers, and we've worked with really big double-digit billion-dollar public companies. And so we've kind of so far worked across the industry, and the thing we've noticed is the problems are very similar across them. So we've been working with big and small companies alike and across industries. We've worked in game development, construction, 3D modeling. We've had a couple clients in that space. and various online SaaS companies. It's really interesting that outwardly we wouldn't expect some of the similarities, but we've seen that there's a lot of common engineering challenges. So far, what we typically do is we treat our consulting a little, I think at least it's unique and a little different. We call it a holistic approach, but all of our team is experienced with both building and developing products and managing teams and building teams. And so we like to go into a client and we focus both on organizational structure and leadership and technology. So we kind of put ourselves out there as architectural consultants, but in reality, we don't believe you can decouple architecture and organizational structure and management. They're heavily intertwined. Mm-hmm. So yeah, that's kind of how we've been approaching our consulting to date. And it's really a wide variety of companies that we've worked with.
Like what specific types of consulting engagements do they bring you in for?
This is what is so fascinating to me. What we actually wind up doing is we often are contacted when someone needs help with, say, performance problems in an application, or maybe they're looking for some assistance figuring out how to run Kubernetes or split up a monolith. We get brought in on those types of engagements frequently. In practice, what I would almost say we help do is help teams get unstuck. So when they're wanting to be able to ship faster, iterate more quickly, it's really like the whole assortment of ways that a team can get hung up. And we come in and help offer some guidance and mentorship on techniques they can use to start iterating more quickly or work through core architectural challenges. We spend a lot of time with groups on how their data is modeled relative to the application design. So are they using stateless systems, or are they putting state in places that are causing fragility in their runtime environment? That type of stuff is what we help clients work through.
Mm-hmm. So really in the weeds consulting on architecture and code decisions, right?
It's kind of high level yet in the weeds. That actually is very much our specialty. Is we approach all of our engagements by first looking at the business and understanding where our clients think they're at today and where they want to be in the future. And then we look at what is their overall architecture and status, and then we help them figure out how to go from where they're at today to where they want to be. Mm-hmm. And we take a mentorship approach. So we'll do a little hands-on coding, prototyping, proof of concept type things. If we make a recommendation, it's something we have done in the past, or we will, help build out a proof of concept to validate. But we require that our clients work with us so that they learn and they don't become dependent upon us. That's kind of a core belief we have, is that if a client brings us in, we don't want to become a blocker in a way to their growth and success. We want to facilitate it. So, we really believe in this sort of mentorship model where we'll help their architects and senior engineers develop the solutions themselves, and we just offer a little guidance. Basically what we used to do with our teams at Workiva.
So do you guys just do professional services, or do you have products as well?
We are starting to work on some products. We have a few ideas that we're starting to really explore and dive into. We've noticed a few common problems, again, across all companies, and we face them at Workiva as well, related to deploying and managing software. At Workiva, we were very far ahead of the curve on things like serverless and usage of containers. And so we have a lot of experience building production systems running on those types of technologies. One of the things we've noticed is that still today, they're not good systems for really, from a business perspective, managing how you release software to a containerized platform, and especially on serverless platforms. There's some challenges that'll come up, such as versioning and even things like service discovery, configuration management. So we're starting to explore what is the really big area of need in that space. And we think that really a nice tool to put some opinionated workflow around life cycle management of those types of systems would be valuable. Our kind of thought process right now is we think it's hard to monetize infrastructure type systems like that, and so our thought is to probably do that open source. In fact, we're now talking about doing a series of blog posts as we build it to discuss all of the design decisions and just building it as an open source system. And basically that would, our monetization model is pretty much like every infrastructure product where it just drives your professional services.
So a little bit ago, you were talking about the importance of the org design and the org structure. Tell me a little bit about your thoughts around that.
So one of the things we have both experienced and observed is that your organizational structure and your systems need to be in alignment. We see this especially when you move, if a company or a product has evolved into a monolith, right? That's like a really common way to start out because it's significantly more efficient when you have a small team and you're moving fast. It's just faster. It's easier to start that way. And then as you grow, you'll start to hit some throughput constraints. Basically, if you have a ton of people all trying to work against that same code base that's all deployed together, it starts to really very, very negatively impact your throughput. And so that's where things like services or at least splitting your monolith into libraries can really pay off. The problem is if you approach that without also aligning your org structures to support that, you'll really have challenges with things like determining priorities. So as an example, let's say you're still going with your monolith and you have multiple teams all trying to release new components. How do you determine priority of release? Because you want to be able to roll back the system if something didn't work right, which starts to really introduce some coordination problems. And that's where things like services can help because you split it into chunks that can be deployed or rolled back independently. But then you start to have different types of coordination problems. You need to figure out solutions to problems like service discovery. And that's kind of what we help companies work through is how do we restructure your org to match that? Because it's a really big problem. You see this with the DevOps movement in particular, where now I think there's a pretty uniform, I shouldn't even say that's not uniform. I think now there's a recognition within some groups that when you separate operations from support or reliability engineering, from product engineering, from your quality assurance team, you really get a misalignment of incentives where the operations people know how to run the system you have today. And so they're not going to be fans of changes getting made to that introduce potential instability. Quality assurance team is held accountable for having found bugs and made sure they're addressed. So they don't want to necessarily see changes going through. The product development teams are held accountable for shipping new features and new products. But all of that results in some incentive misalignment because then you're not encouraging good throughput and iteration. Everybody's intentions are good, but they're not aligned. And so one of the things that is driving the DevOps movement is that problem where you start to combine these teams together and you make everybody's incentive to ship product that's reliable and can be operated effectively in production. So that's one of the big things to work through is how do we align our teams and how do we build incentive structures so that everybody wants to ship a product that's at a suitable quality level. There's a book out, Site Reliability Engineering, that's by the SRE team at Google, and they have this concept of an error budget, which I'm a huge fan of. I've been using similar arguments for a long time. They just put some formal process around it. And the idea is that if you have a team that is a product development team that is shipping, you should have what they call an error budget, where there's a certain number of defects that do make it through, and that way you know the team is being aggressive and moving as fast as you want them to be moving for that area of the product. But they're not spending too much time focused on, oh, well, we need to take 3 more weeks to make sure this thing has 0 production bugs. Instead, they're shipping it, getting it out the door quick, and so you set a quota of, whatever, 1% errors or some kind of metric that you've developed that allows you to say, we don't want you to try to make it perfect. We want you to make it good enough. Here's what good enough means. And if they're having too high of a quality, so to speak, then you need to push them to be more aggressive, ship faster. If they are if they're way under that and they're having way more production bugs, then you slow them down and you stop them and make them go focus and shore up their systems. And so it kind of aligns everybody, because your operations or reliability teams are going to focus on, they know what to expect out of that system, but so do the product developers.
So that's a more aggressive stance on, like Scrum has technical debt, right? So, as you're moving through your sprints and your iterations, you're doing things that you're going to have to go back and eventually fix, but you do it in the sake of speed. Yeah, so having that error budget in place, it's kind of a good bellwether for, like you said, are they taking too many risks, or is there an opportunity to go faster, knowing that more errors are going to be introduced, but that's a trade-off you're willing to make?
Yeah, exactly. And the key thing is it's a decision the business can make. If it's a core system, you're probably going to have a much more stringent expectation about the quality and how many bugs you're hitting. If it's a new product that you're wanting to move fast on, you're probably going to be willing to take a little more risk and be aggressive. There's a book called, I think it's Waltzing Bears Managing Software Projects. It's one of my favorite books. It's a little waterfall-y in some ways, but there are a ton of really good insights and takeaways in it. One of them is that you basically have 3 variables you can adjust on a project. You can adjust your quality, number of features, or date. And so if you're trying to, say on a given sprint, if you're working on delivering a big feature and now it's needed quicker or you want more functionality, you can adjust one of those variables, or multiple of those variables, but those are the things you can adjust to ship. And so if you're working towards a given date, say we want to do a launch of this feature within a month, that may mean you have to give up some other functionality to hit it, or you can adjust quality, which you can measure with that concept of the error budget. Mm-hmm. So it's kind of a cool mental model. I find it very helpful.
Yeah.
What it helps me do is cut functionality out.
Get to your absolute minimum requirements to ship.
Yeah, exactly.
So tell me how cloud changes organizations that you've seen.
Yeah, I have a great story on that. We just helped a client who's moving from it's not technically on-prem at one of their facilities, but it's a colo facility, and they're exploring how to move into either AWS or GCP. So one of the things we realized as we were starting this engagement and we were working through just a few details on how they work, how their systems are designed, one of the things they mentioned that we had literally forgot about was that it can take them days or weeks to provision new hardware and equipment versus the cloud, where we are accustomed to provisioning times of even significant amounts of infrastructure being seconds or minutes. And so you kind of realize how it changes the way you design your software, and it changes also then how you maybe want to lay out your teams. That it's kind of a fascinating thing because you're so much more flexible. You're able to decide, like, hey, we want to launch with this type of machines, knowing that maybe they're over-provisioned or under-provisioned. And then once you actually get some good data, you can just change the machines at a pretty minimal cost, and you can do this in minutes. So it sort of changes your whole thought process. Because if you're building against physical hardware, you need to be aware of what type of machines you're going to be running on, and the cost of those machines is a different type of decision since they're hard to change. You probably don't want to go buy 100 machines configured a particular way if they're not going to work, or they're over provisioned, or that type of thing.
So you've got a credit card and now you have a data center in essence, right?
Yeah, exactly. That's a really fascinating thing of like this build versus buy type decision, right? Now we have a credit card. I can go rent a portion of a data center for however much time I might need. Mm-hmm. It's kind of a thing. It propagates all throughout now. Once you're in the cloud and you're leveraging databases that are run as a service or other core components that are service-based, it really changes how much you're probably going to want to build versus just rent or buy. We actually just put out a blog post yesterday on this topic of build versus buy, and we kind of lay out engineers love to build stuff. They love solving problems, but the reality is we undervalue our own time, pretty extensively undervalue our own time and the cost that we bring by us spending time to go build something. So maybe instead of us, let's say we're a startup and we're launching a product, one of the things you're going to want is logging, metrics, tracing. You need things that allow you to debug and diagnose issues in your system. So one of the things you're going to need to build are tools that let you do that. And there's some good open source solutions, or maybe you decide it's trivial and you can do it yourself. By the time you're all done with that, you may have spent weeks or months of engineering time without even accounting for the operations burden that it's going to bring. Whereas especially if you're a startup, probably you could have just used a service like Splunk or Sumo Logic for $50 or $100 a month. And instead, you've spent tens of thousands of dollars in engineering time and lost time on your own product building out these systems you could have just bought. Mm-hmm. It's something we talk a lot about with engineering teams we're working with. It's really a matter of identify the systems that are core to your business, that are strategic to you, and those are things that are probably worth building yourself so that you have full ownership, or finding an open source thing and really investing the time to own fully. Anything that's like ancillary or supporting, we at least start with this idea we should probably look if we can find an off-the-shelf solution for this and minimize investment in it. That way we're putting the most resources we can onto our strategic value, the things that differentiate us.
So it's almost like you're buying services as a service, right? We had software as a service, which is like Salesforce. Then you had infrastructure, compute as a service.
Yeah.
But if you're able to go out to, and I assume there's an app store, right? Like I think you mentioned Firebase or Firestore, where you can go and buy these applications. Are they applications or are they services that you're renting?
It's kind of interesting, like talking about Firestore. It's a new product offering by Google based off of Firebase. And it's so fascinating because it's almost as if though it's in the middle. I shouldn't say in the middle. It's kind of a lot of things because you can use them to do your authentication. So Firestore, I can just go click. I want Google login, Facebook login. You can pick what you want to authenticate. They provide the backend systems that are going to store your data, and then you can kind of plug in your functions into it's a serverless system called Cloud Functions that I can go write a function then to manipulate my data, perform data validation, send notifications, basically all of these things you would normally need to be building out. And instead, we're going to pay a usage-based fee and expense. And maybe it depends on which services I've enabled or not on how we're billed. But it kind of allows this interesting a la carte model. So it's not really, at this point, I think that's a gap, by the way, the App Store, this idea of a serverless App Store. It's something we've talked about product-wise, is should we go build a almost like a search engine for serverless functions that you can just plug into your app, or even an app store that allows people to publish a function that maybe you can just go buy for, some nominal amount of money, that you're able to go buy a function that, does some common need. It's a gap, I think.
So these are basically like APIs, right? So
yeah, exactly.
You plug in a line of API code,
yep,
and it returns whatever you need versus investing your time and dollars to create that service yourself.
Yeah, exactly. It's actually a term that we use as this idea of API-driven development, where you expose your database via APIs that are accessed maybe via RPC or asynchronous messaging as an example. And by doing that, it means your developers don't necessarily have as fine grain of control and access to the database, but now they can focus on the core logic, and they're instead approaching it from the standpoint of, okay, I just have this API to work against. What that gives us then is this idea of abstraction layers. So now we can swap the database, or the operations team can make adjustments to this underlying system, and we don't have to go re-architect our entire application, as long as we understand what are the expectations of this system. Is it transactional? What kind of performance can we expect? If we understand, is it fully synchronously fully consistent, or is it eventually consistent? If we understand those types of things, then we can make as many changes as we want to the underlying systems without having to redo large portions of our higher level application. That's a lot of power to that type of mindset and model.
So that also helps you avoid the pitfalls that come with vendor lock-in, right?
Yeah, exactly. It's such a big thing. We hear pretty much every day this idea of vendor lock-in comes in on why don't we want to use a hosted solution or a particular cloud provider's offerings. The thing about vendor lock-in is that you're getting locked in because they're providing value, right? Like the system they're building, you're locked in by virtue of the fact it's providing value. But it's not as big of a problem as I think we make it out to be, because it's possible to build your systems so that it's without having to over-engineer things. You can put small, we call them abstraction layers in, that just kind of decouple maybe your application from whatever this underlying system you're worried about being locked into is. You can decouple slightly from it so that if you were to need to switch out to a different solution, it would be possible to do so without requiring a full rewrite. We've actually helped companies, and we've done this with some of our own products, where even though we're building on very proprietary platforms like Google App Engine, we'll use those types of systems to accelerate our initial development and release of a product, but with a little bit of upfront design and engineering, we've been able to make it so we can move those systems off onto other platforms with no major downtime, and even do it pretty quickly, which gives you a lot of power, because that means you don't need to move off until there's a compelling reason to do so, right? Until you're kind of at a level. This goes back to the build versus buy in a lot of ways. There's this idea of capital expenditures, which is effectively paying up front, or an operational expenditure, which are the kinds of things I can throw on my credit card or something like that, and we pay for over time based on use. All of these things kind of interplay together, because if we design things smart, if we put in that upfront effort, we can make sure in the beginning, we can basically treat these like an OpEx, right? An operational expenditure. We can just pay for what we're using. We don't have to go buy 100 or 1,000 machines. Instead, we design the software so that we can use usage-based systems. And then as we achieve success, maybe we can start moving pieces of this to a more capital expenditure, where we upfront pay money to get better utilization and reduce our overall expenditures. Those are those are pretty complicated ideas and topics, but it's something a lot of people don't necessarily put in the effort to think through. And they'll put in a lot of time up front, which is, really just slowing down your time to market and ultimately holding you back because you have much larger sunk costs.
So when is it okay to bring stuff back in-house? I mean, you mentioned, does it make sense operational-wise to put down a large chunk of money? But there's got to be other decisions that go into that as well, right?
Yeah. One of the things we've seen is when you have an existing product that's pretty stable and it's a pretty known quantity, basically once you have a good handle on things, you have an operations team and a reliability group that's very knowledgeable and experienced, there's just not a lot of variability left. For lack of a better term, you bring it back in-house. So if you're cloud-based, what that probably means is maybe you're going to be switching and doing 3-year prepays or reserved instances just to reduce your monthly expenditures and minimize overall expense. That's kind of the analog. So it's really, I think it comes back to, do we have a good handle on things? Do we know, can we predict them accurately enough that if we go prepay for a bunch of machines, we're confident that for the next 3 years or 5 years, those are the machines we're going to need. In terms of the build versus buy of just software components, it's really, we're huge fans of you start using as many hosted things as possible just to focus on your core business logic and differentiators. Over time, your idea is to reduce maintenance burden, reduce expense of operating the system. And so you may decide, hey, we want to switch from this hosted solution we were using. Maybe our product is stable enough that now we can start to allocate engineering time that will ultimately reduce our overall operating expense. So maybe you move that logs solution from the hosted thing. Maybe you decide it's worthwhile to invest in running your own Elk stack, or maybe started with some other type of authentication provider, an Okta or something like that, and now we're going to go set up our own Keycloak cluster and bring auth back in-house. That's probably not a core differentiator, but maybe now we have some excess engineering capacity. We can use that and reduce our monthly expenses. That's kind of the thought process as we go through on build versus buy and generally bringing solutions back in-house.
Mm-hmm. So do you still do DevOps within your development team if the application's in-house, or is DevOps just that persistent throughout the life cycle that it's always there no matter if it's hosted or if it's outsourced services?
Yeah, that's actually a really good question. I have a talk I like to give, or I've given a few times rather, that's called Evolving and Scaling DevOps. And one of the first things you have to talk about if you're going to talk about DevOps, you actually have to define what does that even mean. And it turns out it's like a really complicated thing to even define. I call it an ineffable term. It's like almost impossible to actually define. So instead, I talk about the ideals, the things you're trying to achieve with DevOps. And what you're generally trying to achieve is to get better resource usage. Resources meaning your people, which are probably your most expensive thing by, perhaps by an order of magnitude or more. Mm-hmm. So you're trying to get better usage of your resources. You're trying to get better alignment of your resources. That doesn't change. You get those divides in the groups. You get those silos because everybody has specialized skills. The operations people know Linux very well. They understand networking, and they understand all these little nuances of actual production clusters in a way that's probably different than your engineers who maybe understand architecture and algorithms, and they understand a different set of things really well. And so the groups segregate so they can specialize. Well, over time, as you're maybe investing less in the engineering component and more of the time is really in the operating expense or reliability and support expense, I don't think it changes DevOps. I think you still use those ideals. You just have to look at the silos, and DevOps is DevOps tries to eliminate or reduce the siloing. And the way you do that, I believe, is through products. You basically build products that enable you to scale that specialization. So I don't actually think it reduces your investment in DevOps. It just may change how you're investing. If it's a product that's in maintenance mode, maybe you're not going to invest as heavily in enhancing your release processes as such. Maybe you're going to invest more heavily in a lot of the supporting tools and the tools that automate operating aspects. Maybe that maybe you look at it and you say, hey, there's some kind of memory leak and this service needs restarted every 2 weeks, or it hits production issues. So, maybe you're going to then make a trade-off decision of we're not going to invest engineering time to triage that. Instead, we're just going to build operation tools to restart that service every week or day or, whatever is appropriate. And I think that's how it changes it. So I know that's kind of a rambling answer, but it doesn't necessarily change your the need or value of DevOps. It just changes how you allocate investments within this kind of DevOps ideal.
Mm-hmm. So you solve for the problems more process related than you do development related, right? At that point.
I think it allows you to make that decision. It's how I would think of it. Like sometimes you're going to look and you're going to decide that adjusting a process is going to give you the value that you're looking for, and sometimes it'll be engineering time. I think that's the key thing, is it lets you have a discussion to make that decision as a group.
Yeah, that's a really smart way of looking at it, right? I mean, do I spend the dollars to go and fix it, or do I put processes in place to recover those failed services or restart those things that, inline corrective actions?
Yeah, exactly. I mean, the ideal is you're dealing with as many things as possible in a proactive way, but there's also a point with some problems that it's better to be reactive while you're learning about it. Sort of funny to actually say that out loud, I guess. Really, generally I don't encourage a reactive approach, but the reality is when you're hitting some problems and the point in a project's life, what you want to do is turn a reactive solution, for example, restarting a service, into a proactive solution, restart it more frequently than it crashes. Mm-hmm. I think that's a kind of discussion you can have, really.
Just having the ability to have that discussion is probably fairly powerful too, right? Giving you more options how to deal with a problem.
Yeah, exactly. I mean, it may be the case. We have our engineers off working on a new product that's core to the business, and it's just not worth their time to go back and address a product that is in maintenance mode. Or, something that's generally stable and we have a bug that crops up once every 9 months. Maybe we're better to just automate that response to that issue when it pops up instead of allocating weeks of time to go diagnose it and release a new fixed version.
So Robert, the talk was fairly detailed and there's a lot of terms that some listeners may not be aware of. Do you have any educational or learning resources that you can point people towards?
Yeah, if people are interested in this kind of DevOps type thing in particular, I think the SRE book, it really goes in depth on a lot of these topics. When I was really building and developing Workiva's sort of DevOps org, I actually bought a whole bunch of copies of that book, and I handed them out to as many people in the engineering department as I could get to read it, just so they kind of understood what we were trying to build. That book is a good resource for just thinking about architectural considerations. I think highscalability.com is a pretty good resource. Those are probably a couple generally good resources. Of course, Real Kinetic's blog, I would also say.
Definitely send people there. So the SRE was Site Reliability Engineering, and that was by Google, right?
Yeah, yep.
All right, I'll put links in the show notes to all these books so people can find those.
The other book that I actually mentioned earlier is Waltzing Bears Managing Risks on Software Projects. That book, there's a lot of there's some pieces I really don't necessarily buy into, but a lot of the stuff I find it really insightful and valuable. So that's actually another one I would suggest people take a look at. Another book, actually, I'm a huge fan of for alignment. Actually, there's two books, two other books I would suggest that are just good general books. So we started using a technique called objectives and key results. I think it is a phenomenally amazing technique for driving alignment of your resources. It's not always obvious when you first start using them, but as you get better at using OKRs, one of the things it'll do is start forcing representation from different teams and different groups to sit down in a room and agree on priorities. So there's a book called Objectives and Key Results, Driving Focus, Alignment, and Engagement with OKRs. I would highly suggest that. I've got a blog post where I try to sort of summarize a few of the key things about OKRs, but that book I really would encourage people to take a look at. I'm a huge fan of that process. The other one is if you're managing a large group, there's a lot of ideas from just management leadership that I believe in, but there's a book called Team of Teams, New Rules of Engagement for a Complex World, and I think there's a lot of really good ideas in that book as well. Those are a couple things I would suggest.
Yeah, I've read Team of Teams. I thought it was a really good book as well. So.
Yeah, I liked that. I think it's good. I used a lot of similar techniques when I was managing a larger group at Workiva.
So, Robert, how can people find more about Real Kinetic?
I think the best resource is probably our website, realkinetic.com. We have a blog. We're really trying to get systematic and disciplined with releasing blog posts now. It has a lot of kind of information, both technical. Also, we try to put stuff out on leadership and management because, as I mentioned, they're pretty heavily intertwined with your technical decisions. That's probably the best. We are on LinkedIn, Twitter, Facebook. We have presence on all those things to some extent. Yeah, our Twitter handle is @real_kinetic. My personal Twitter handle is @Robert Kluin.
All right, Robert, I appreciate you coming on Colorado TechCast and telling us about Real Kinetic. You talked about a lot of really interesting things in terms of DevOps and metrics that we can use to measure if our team's being too aggressive or not aggressive enough. And I think you gave a lot of really good book recommendations as well. So we'll have links to all of those in the show notes for this.
Yeah, awesome, Trapper. Thank you for having me. I had fun, enjoyed it.
Thanks for listening to this episode of Colorado TechCast. To hear more episodes of this program, visit our website at coloradotechcast.com. There you'll find everything you need to know to subscribe to the show. We're also on Twitter @COTechcast and love hearing your comments, so keep them coming. I'm Trapper Little, and I'll talk with you soon on the next episode of Colorado TechCast.